Hello, ICP, and welcome back to your notes on the Big Bang. This is part 2, and we're going to be talking about pieces of evidence that support the Big Bang theory. There are 3 big pieces of evidence that support this theory. One of them is the background radiation that's left over in our universe. We think that that's an echo or a fingerprint left over from the Big Bang. The second piece of evidence is how abundant hydrogen and helium are. There are extremely large amounts of hydrogen and helium in outer space. And the last piece of evidence is redshift. And that's kind of a visual effect that we can see that shows us that there are galaxies far away from us that are moving even further away from us. Today is all about these 3 pieces of evidence, and we're going to dig into each one and explain it more. First, let's talk about background radiation. You might remember from last time that the first atoms were formed 379,000 years ago. Those atoms were hydrogen and helium atoms. You can tell in this diagram the nuclei with 1 proton, those are hydrogen atoms, and the helium atoms have 2 protons in their nuclei. It glitches on this, so I'm gonna have to go there. And there we go. Sorry about that little moment. Okay. We're back. We're still talking about how atoms formed, and that caused an incredible burst of energy. That was a high amount of radiation, and an echo of that is still present today. So the energy that was released when atoms were formed was released as heat, billions and billions of degrees of heat. This makes sense because every single atom, when it was formed, released some heat. And there were so many atoms of hydrogen and helium, and that's what accounts for how high those initial temperatures were. In fact, scientists think that our universe is still cooling today. Scientists hypothesize that that temperature of billions of degrees was so hot that our universe is still cooling, and they estimated that that burst of energy of all of those atoms forming was so powerful that we still have an echo or a fingerprint of radiation that it should have left behind. So we predicted that we should be able to see or measure some kind of echo of the Big Bang, and we would see it as radiation. Well, in 1964, 2 scientists named Penzias and Wilson accidentally discovered the echo. So we had a theory that this existed, but we finally saw the evidence in 1964 that there was radiation in our universe left over from the Big Bang. Penzias and Wilson worked with a very sensitive radio telescope. That's a telescope that visualizes radiation. And it picked up this inexplainable radio static all over our universe. They concluded that that static was the echo from the Big Bang itself. This is their experimental data. It's called the W map, and it's a map of the radiation left over from the Big Bang. It's basically showing us the temperature of our entire universe. You can see there are some hot spots and some cool spots, but all of that leftover energy is an echo or a fingerprint from the Big Bang. In fact, you experience some of this data yourself. Some of the static that you might hear on the radio or see on your TV, that's actually an echo of radiation from the Big Bang. We're moving on to the next piece of evidence now, so that's enough about the radiation echo. Now we're going to talk about piece of evidence 2, the abundance of hydrogen and helium. The scientist George Gamow hypothesized that the heat and energy of the Big Bang created all of the hydrogen and helium in the whole universe. He also helped us prove that today's universe, 99% of it, is made of hydrogen and helium. So it makes sense that hydrogen and helium would be the picks for the most abundant elements in the universe, because they're the smallest and the easiest to build. So here they are in the periodic table. They're the smallest because hydrogen only has 1 proton in its nucleus, and helium has 2 protons and 2 neutrons in its nucleus. Every element that comes after that is larger and more complicated, so it makes sense that they were made first and in such large amounts. When we look at our universe and see that 99% of it is hydrogen and helium, that gives us a good piece of supporting evidence that the Big Bang is what created such large abundances of those atoms. Think to yourself, here on Earth, we have hydrogen. We have things with hydrogen in them. What do you know that has hydrogen in it? If you said water or anything else with hydrogen in it, you just named something that has an atom in it that came from the Big Bang itself. Every single atom of hydrogen and helium can be traced back to the Big Bang. So what I'm telling you is, I have a bottle of water here. It's full of H2O. Every single hydrogen atom in this bottle is basically stardust because it came from the Big Bang itself when hydrogen atoms were first formed. And you might know that humans have a lot of H2O. We have a lot of water inside of us. So yes, that's right. You are made of the stuff that stars are made of, and you are stardust. We're on our last piece of evidence, the faraway distance of galaxies. Most of the galaxies that we can see are moving away from Earth, and the ones that are further away are moving even faster than the ones close to us. This is good evidence that the universe was and still is expanding as the furthest galaxies push further and further out into the expanding universe. If all of the galaxies are moving away from each other now, then they must have been closer together in the past, because galaxies can't really change the direction that they're going in. Sir Edwin Hubble was the scientist who discovered that most galaxies are moving away from Earth, or in other words, moving away from our galaxy, the Milky Way galaxy. He first proposed that if all matter in space is moving away now, then it must have all started moving from the same spot, and it hasn't changed trajectory since. So that concept that if all galaxies are moving away, and they always have been, then they must have come from the same spot is called Hubble's law, because it was proposed by Sir Edwin Hubble. Look at him in his pipe. Visually, we can tell which galaxies are moving the fastest and which ones are moving the slowest. So you can see the Earth and a lot of colorful stars around it. This portrays how we on Earth see different stars as different colors. The further away a star is and the faster it's moving, the more likely we are to see it as a red star. If it's closer to us and moving slowly, we are going to see it as a blue star. This will be explained in some work you'll do in your virtual notebook, but basically, have you ever had someone in a motorcycle drive past you and it sounds like I hope you enjoyed that. So the sound is a wave, sounded very high frequency when it was approaching you, but then as the motorcycle rode away, the wave became lower frequency as it drove away from you. Light is also a wave, and it does that same transitioning. It appears different coming towards you than it does moving away from you. Long wavelength light is red light, so if you see a star that looks red, that means it's moving away from you. It's like hearing a car go, you know it's moving away from you because you're used to that sound. Same idea. So one more time, that red star is further away from Earth and moving faster into the expanding universe. The white star is closer to us and moving much more slowly. I hope that was helpful. I'll see you guys later in class. Come to the Google Meet if I can help you.